Hello, everyone, and thanks for joining us for the 7th annual The Science of Cannabis Testing 2023. I'm Roxanne Newman, Senior Manager for Webinars and Online Events, and I'm here to moderate today's event alongside my colleagues George Hammond and Princess Sunit. Before we start the talks today, I just have some general information and a few tips for getting the most out of the event. We would like to ask if you could please refrain from video, audio, or photo recording of all talks. Many of our speakers have kindly agreed to share their slides with you, and these are available within the literature section on the platform. Please remember that we encourage debate and discussion and welcome all of you to use our networking services to introduce yourselves to other attendees, but we do not permit the overt solicitation of products or services and reserve the right to block any user who infringes on this rule. It is also incredibly important to say that this event was only made possible thanks to the generosity of our sponsors and partners, particularly our platinum sponsor, Millipore Sigma. For more detailed instructions on how to make the most of the features available to you at this event, please navigate to the event home and watch the overview video at the top of the page, or you can visit the FAQ section in the left-hand menu. With that out of the way, I will now hand over to Princess to present our opening session for the event.
Thank you, Roxanne. I am pleased to welcome Jini Glaros, who will be presenting this first session today, Accuracy versus Efficiency, Streamlining Your Potency Processes. Jini is the Chief Scientific Officer at Modern Canna Labs in Lakeland, Florida. She received her bachelor's degree with honors in biochemistry from the University of West Florida, and in May of 2022, Jini earned a master's degree in medical cannabis science and therapeutics from the University of Maryland, Baltimore. Jini is extremely involved in the cannabis industry and currently serves on the Scientific Advisory Board for Analytical Cannabis and Cloud LIMS. She is a member of the CASP Proficiency Testing Advisory Task Force with AOAC International and a member of the Cannabis Working Group D37 with ASTM International. Following the presentation, we will have a Q&A session and we welcome any questions that you may have. Please ask questions using the Q&A system to the right-hand side of the video player. And without further ado, I will now hand over to Jini to begin her presentation.
Thank you, Princess. Today, I would like to discuss a very important topic that I believe is important for the cannabis industry, and that is going to be accuracy versus efficiency and streamlining your potency processes. So when it comes to potency testing, this is something that is definitely scrutinized by producers, by consumers, everyone. And so it really is imperative that laboratories are producing data that is accurate, reproducible, and legally defensible. So first up, I would like to discuss potency. And while most of you attending this presentation are probably already familiar with potency, I do want to do a quick review of the topic. So potency is going to be that measurement of the concentration of cannabinoids that are present in a sample. And this could be a flower sample, a derivative product, or an edible product, anything really. It's just looking at that overall cannabinoid concentration. And this testing includes both major and minor cannabinoids. And typically we see laboratories running about 11 to 16 different cannabinoids regularly. The most common ones are going to include things such as D9 THC, THCA, Delta 8 THC, CBD, CBDA, CBG, and CBN. However, there are others included to get you to that, 11 to 16 sweet spot we kind of talked about. And in order to determine the concentration of cannabinoids that are present in a sample, the samples have to be extracted and diluted accordingly. And then once that happens, then a liquid chromatography technique is going to be used to separate and quantify the cannabinoids. And typically we are seeing laboratories using HPLC or high performance liquid chromatography. However, there are more laboratories who are starting to move to LCMS, which is going to be liquid chromatography with mass spectrometry. So I'm sure many of you know that with potency testing comes cases of potency inflation. And we are seeing this really all over the United States. And while it does seem like it may finally be getting better because we are seeing some repercussions for people, it is still a real problem that is negatively impacting the industry. And if you are not familiar with this term, potency inflation is going to be where laboratories are reporting cannabinoid concentrations at levels that are greater than what is truly present in the product. And so we see this a lot in flower. I'm sure there are plenty of cases where we're also seeing it in other product types. However, it may not be as noticeable as the flower. When you see a 45% THC flower on the market, it's a little bit more noticeable that those numbers are inflated. And one of the issues that accompany potency inflation is going to be that it's really giving consumers a false representation of what is actually present in their product. And at the end of the day, this, could be considered consumer fraud. However, the bigger issue with inaccurate reporting of cannabinoids is going to be that it impacts dosing. And we have heard some people say, oh, well, if it's a recreational market, dosing isn't as important. However, a lot of markets are medicinal, and even in a recreational market, I think dosing could be very dangerous if people are consuming an amount that's not correct, if they're consuming, more or less than what they think they are truly consuming. And really, when it comes to potency inflation, we're really seeing two explanations for why it's occurring. And the first is going to be that some laboratories are ultimately knowingly inflating their results. They're manipulating the sample, whether that be through the sample preparation process or the analytical process. And when it comes to sample preparation or sample manipulation, this can be done through that sample collection, the homogenization, the extraction, or even the dilution process. When it comes to the analysis side, it can be done by manipulating calibration curves or changing chromatography, or even by doing something as bad as dry labbing. So saying you ran a sample when you really didn't. And the reality is, at the end of the day, is that THC sells. And so some labs are desperate to keep business. And as a result, they're making the decision to go down this path. I think it's important to note, however, that not all laboratories are maliciously manipulating their data. And that really brings us to the second reason why we see potency inflation occurring. Plain and simple, there are laboratories which exist that do not realize that their processes are leading to inaccurate quantification of cannabinoids. And so because of that, there is this bigger problem, right? They do not have the skill set or the knowledge to identify the issues, or they haven't taken the time to investigate how their processes are impacting that final number that's being reported. And this is really the portion of potency inflation that we're going to focus on today with the presentation. So when we talk about potency analysis workflow and all the steps where bias can be added to the process, we can really break it down into the following categories. The first being sample collection, then sample homogenization, sample prep, analysis, data evaluation, and data review. And we could talk about all of these in depth, but for the purposes of today's presentation, we're really going to focus on the sample prep side of things. So since we're going to look at sample prep, I would like to break that down even further into 4 separate categories, which is going to be weighing the sample, addition of solvent, extraction of cannabinoids, and preparation of dilutions. And I really hoped that I would have time to touch on all 4 of these during today's presentation. However, that as far as time goes, I don't think that's going to be feasible. So we're going to focus on 3, which is going to be the weighing the sample, the addition of solvent, and the preparation of dilutions. However, I do hope to have a future presentation on the extraction of cannabinoids. This is really one that's very involved. It involves looking at things like extraction solvents, extraction times, extraction techniques. And it's a pretty big undertaking that would probably fill up this entire time slot. So we're going to touch on the other 3, and then maybe hopefully I'll have a presentation for you in the near future looking at the other one. So when we talk about sample weighing, this is the first portion of sample prep that I want to discuss. And when you think about sample weighing, theoretically, the more you weigh, the more reproducible of a result you will obtain. And that's really because the more representative of the sample you have. And also any slight variations you see in that weight on the scale are going to have less of an impact on that final result. So that's the theory. How do we test that theory? And so the following experiment was conducted. So what we did here is we took a THCA concentrate sample, and it was prepared at 4 different weights, and then each of those were prepped 7 times. So the 4 weights that we tested were 10 milligrams, 50 milligrams, 100 milligrams, and 200 milligrams. And once those samples were all weighed, they were extracted, diluted, and analyzed identically. We did the same process for everything to ensure that we kept everything uniform there. And once they were analyzed, those THCA concentrations were taken and looked at and calculated so that we could look and see what variances we were seeing. And the reason we chose to look at a sample like this, a THCA concentrate, is because they're inherently known to be non-homogeneous, and therefore, depending on that sample weight, you may see changes in the variability of those results being obtained. And so you would see a similar process, right, with flower material, which are also very heterogeneous in nature. So the results of the experiment are included in this table, and you can see here that as you increase that sample weight, you're really decreasing that variability that is seen in those results, as well as the range of the values that were obtained. So when you weigh that smallest amount of 10 milligrams, we're seeing a standard deviation amongst the 7 results of 1.65, with that relative standard deviation coming in at 2.03%. And the results are ranging from have a range of 4.17%. So you may have gotten 78 and then you got 82.5. However, once you increase that weight to 100 milligrams of sample, that standard deviation decreased to 0.97 with a relative standard deviation of 1.22 and then a result range of 2.98. And those results will get even smaller once you weigh that 200 milligram sample. However, based on preparation schemes, this weighing 200 milligram results in needing to use more solvent or create a larger dilution. So of course, when you use more solvent, you're increasing the cost that's associated with each sample, or if you're to increase that dilution, there's a chance that more variability could be introduced by that additional step. So as a result, our laboratory has concluded that 100 milligram sample weight is sufficient in producing an accurate result while still taking the efficiency and the cost effectiveness of being a commercial laboratory into consideration. I do want to mention that this weighing scheme really only applies to those high concentrated THC products or CBD products. So ones with cannabinoid ranges of greater than 50%. And other weighing schemes are gonna have to be developed for different sample types. And so we really encourage that all laboratories run this type of an experiment and investigate, what is the proper sample weight to use based on my product type in order to produce that accurate value. So the next part of the experiment is going to be looking at the addition of solvent and how that impacts the preparation. So in order to do this, we created the following experimental design, and we used 6 different sample types. So the first 3 sample types that we looked at are going to be some THC flower. So one with a high concentration of THC, a moderate concentration, and then a lower concentration of THC. And for these samples, we prepared each of them in triplicate, and then they were also had the solvent added via 3 different techniques. So the first being a mechanical pipette, the second being a bottle top dispenser, and the third being a volumetric pipette. Similarly, we did the same thing with 3 different types of derivative products. So one being a THC distillate, one being a tincture, and one being a THCA concentrate. And in this instance, that was a butter. And again, each of these samples had solvent added using the mechanical pipette, the bottle top dispenser, and the volumetric pipette, and they were all prepared in triplicate. Once the solvent was added to these samples, we then followed our normal extraction and dilution procedures for all of the samples and compared the results. So as expected, the volumetric pipette, which is definitely known to produce the most accurate results, had that lowest average relative standard deviation, which was a value of 0.846. This was followed by the bottle top dispenser, which produced an average RSD of 1.13. And then finally, that mechanical pipette that had an average RSD of 2.03%. And really, since this presentation is focused on accuracy and efficiency and helping laboratories produce accurate data in an efficient manner, we also recorded the average time it took to add solvent to each sample. And you'll see there that the slowest option was definitely the volumetric pipette, which took about 1 minute per sample. Granted, we do not use these super regularly in our laboratory, so I'm guessing we could get that number down a little bit once we improved our processes, so maybe 45 seconds a sample. However, with the volumetric pipette, you have to be exact and you have to measure that meniscus correctly to obtain an accurate measurement. And so it can really be more time consuming in general, just because of those implications and how difficult it is to measure that. The time for the bottle top dispenser and the mechanical pipette were very similar. The bottle top was about 15 seconds and the mechanical pipette was about 20 seconds. I do want to say that the mechanical pipette was more difficult, simply because you had to be careful that the solvent did not drip from the pipette tip when trying to transfer it to the sample container. And that's something we'll talk about a little bit later, in vapor pressure and how that impacts delivery of solvents when using a mechanical pipette. Ultimately, based on the results of this experiment, we have concluded that the most efficient, simplest, and still extremely accurate way to add solvent is going to be using a bottle top dispenser. With this and with any processes you're doing, you really have to make sure that your processes are working properly. And so in order to do that, we do check our bottle top at the beginning of each day to make sure that it is dispensing accurately. And then we also prime that bottle top multiple times before each batch is prepared to ensure that we remove any air bubbles. And that is to make sure that we're not impacting the amount of solvent that's being measured or delivered to those samples. So the final thing we're going to look at is going to be dilution prep and how that impacts those final results and that accuracy and efficiency in the laboratory. And this is an extremely important process, important part of the process, especially when considering the concentration of cannabinoids that are normally present in the sample and the dilution that has to be done to get those cannabinoids into the calibration curve. So whenever you think about cannabis and you think about your calibration and the restrictions of the standards you can get, laboratories are normally doing anywhere from a 5,000 to a 10,000x final dilution. So any skew in that dilution can drastically impact that data. So we need to make sure that whatever dilution process we're doing is not causing that data to be skewed. So in order to do that, we designed the following experiment, and it really just built on that last experiment that we did. So as you can see, we have the three different types of flower with the varying ranges of THC present, and each of those samples were prepped in triplicate, and each of the samples had the solvent added in the three different ways. So using the mechanical pipette, the bottle top dispenser, and the volumetric pipette. And then once that was done, those samples were extracted the same exact way, sent through the same exact extraction process. And then from there, dilutions were prepared using a mechanical pipette and a gas tight syringe for each of them. And they were all prepared in triplicate so that we have, reproducibility results to compare. We did the same thing with that THC distillate, the tincture, and the THCA concentrate as well. Again, preparing those samples in triplicate via each type of solvent addition, and then diluting each prep using the mechanical pipette and the gas tight syringe. And really the great thing of doing this and taking that experiment a step further is that we were able to see the compound error that occurs, as well as like the overall and individual error. So we're able to look and say, okay, when you use a mechanical pipette in the first step and then you use a mechanical pipette to dilute, you get this. When you use a mechanical pipette, but then you use a syringe to dilute, you get this, and so on. So it really helps us be able to look at the big picture of how results are being impacted throughout the process. So in this table, I have broken down those results based on the way that the solvent was added and the dilution technique that was used. So as you can see, there is a drastic reduction in the average relative standard deviation across all solvent addition techniques when you're comparing the results that were obtained when the dilution was performed using a mechanical pipette versus when the dilution was performed using a gas tight syringe. And if we look at that bottle top dispenser result, you can see that that preparation had an average RSD of 5.66% when a mechanical pipette was used to perform that final dilution, whereas that was reduced to 2.82% when using a gas tight syringe. And really this results in a 50% improvement in the reproducibility of the results that were being obtained. And you can see similar results are obtained for both that volumetric pipette and the mechanical pipette. And overall, the use of that gas tight syringe was able to improve the reproducibility and in turn, the accuracy of those results by about 55% on average when looking at all of the different solvent technique additions of how you're adding your solvent to the sample. So a pretty drastic improvement across the board by switching to using that gas tight syringe. In addition to looking at RSDs, we also wanted to look at RPD, so relative percent difference. And this, in order to do this, we had to run the samples at 2 dilutions. So we took the sample and we ran that original, what we're going to call a 1x dilution that was really, a 50x or 100x dilution, depending on how much sample was weighed. And then again at that 100x dilution that we did. And by doing this, we were able to compare and say, okay, if I have 78 and I have 82, that's a RPD of 5%. So this is the RPD between my two values. And in order to, how we chose what we looked at is we chose an analyte that would be in curve at both that 1x dilution and that 100x dilution. So something that may have come in at 78, like I said, on that 1x, and then came in at 0.82 on the 100x would be a value of 78 compared to a value of 82. And we were able to compare those values and see just how similar they were. And you can see in this graph that 54 of the samples that were analyzed here, of those, the dilutions that were prepared using the mechanical pipette, we saw 40% of those dilutions coming in with a RPD of greater than 10% between the two dilutions. Whereas when we did the gas tight syringe, we only saw about 5% of those dilutions having an RPD of greater than 10%. And you can see the gas tight syringe values are displayed in green and the pipette values are displayed in orange there. And with this, you can also see that the reproducibility of what we're getting with the gas tight syringe is much tighter than what we're getting with a mechanical pipette. So you can see sometimes with that mechanical pipette, you get a really low RPD, as in what you see in sample 17, but then you go to sample 31 and you see an RPD of almost 20%. And so this really talks about why, when solvent is involved, we need to be using gas tight syringes, and why it's a better option than a mechanical pipette. Yes, a mechanical pipette may seem like a quicker or a simpler option to train someone on, but at the end of the day, the mechanical pipette has issues because of the vapor pressure that we're seeing in the solvents. So with solvent, the vapor pressure is going to be different from solvent to solvent. And so we like to say that sometimes that tip, you take up that solvent and now you have a drippy tip because you have solvent leaking out as you're transferring it. So you're not transferring an accurate amount, and thus seeing quite a bit of variability from prep to prep. And I will say, training someone to use a gas tight syringe is probably a little bit more difficult than training someone to use a mechanical pipette. But at the end of the day, that training, going a step further and training someone to use it to produce a more accurate value, is definitely the way that laboratories should be going. So now that we have reviewed all of the different processes involved, I would like to go over some conclusions and some recommendations. So first, laboratories should ensure that they are weighing enough sample to generate reproducible data. And at times, for efficiency purposes, it may seem like weighing less sample is a good idea because you won't need to do a larger dilution, or you won't need to use more solvent. However, due to the heterogeneous nature of many cannabis products, it really is a good idea to conduct validations on the sample amounts being used for each type of analysis to make sure that that's not going to impact your reproducibility. Second, the use of bottle top dispensers for the addition of solvent really is going to be the most efficient way, and it really doesn't drastically impact the reproducibility or the accuracy of the preparation. And, at the end of the day, yes, the volumetric is the most accurate, but when it comes to adding solvent and using a volumetric pipette and measuring correctly, it also can introduce the most human error, and it has the most difficulty accompanied with it. So it's definitely a give or take kind of thing. The differences weren't drastic enough between the two to indicate that, oh, we definitely need to be using these volumetric pipettes in the laboratory. And this is something that we didn't discuss, however, in depth. However, it is something that I would like to mention, and that is that really calibration should be prepared in a manner that is identical to the samples. So that means that if you're preparing your dilutions using a syringe, then that's how you should prepare your calibration. Similarly, if you're preparing your dilutions using a mechanical pipette, then that's how you should be preparing your calibration. And really the same goes for gravimetric preparations. So if the laboratory were to be preparing their calibrations gravimetrically, they would want to make sure that they were also preparing the samples in that same way. Next, utilizing syringes for dilutions really is imperative to obtaining the most accurate analytical results. And I think this was clearly portrayed on the last few slides when we looked at both the RSD of the results and the RPD between the dilution preparations. Ultimately, by using that gas-tight syringe, any issues that may arise due to the vapor pressure of the solvent or the diluent being used can be eliminated. And finally, this is one that we didn't really touch on in depth as far as our processes, but internally we run all of our samples at 2 dilutions. And this really has 2 benefits. One, it's going to improve your detection limits, which is important for those minor cannabinoids, which we know are becoming more and more interesting, more important. People are looking for them. And second, it also helps ensure that that dilution is not skewing the data. And when we talk about the dilution skewing the data, we're talking about that big 5,000, 10,000x dilution that labs are doing. And how is that impacting the number? When you're looking at ppm to percent, if you're doing a 10,000x dilution and you have a value of 1 ppm versus 2 ppm, that's a percent difference in those results. And so it really does have a big impact at the end of the day. So yes, it's a little more time consuming and takes twice as long to run each sample, but really it has drastically improved our accuracy, and our clients have been very receptive to the fact that we're also able to better quantify those minor cannabinoids. As a few final notes, I do want to discuss why accuracy and efficiency are important for a commercial laboratory. So, by ensuring both accuracy and efficiency for sample prep, the laboratory can prevent reruns due to errors that occur from those preparation procedures. And we covered these topics pretty in depth on the previous slide, so I really won't go into much detail. But again, if you're weighing too little sample, that reproducibility of the data can be negatively impacted. Additionally, if a mechanical pipettes are used in the process and the vapor pressure is impacting it, then you may be adding an inaccurate amount. And then finally, while that volumetric pipette, yes, is the most accurate and extremely accurate method, it also can be very time consuming and it can be difficult to use. So as such, the data presented shows that there are ways for a laboratory to still be accurate and efficient at the same time. And so I think that's an important part of our processes, right? As a laboratory, we need to say, okay, how can I be the most accurate as possible while still being efficient, while still being a commercial laboratory who has to run 200 samples a day, 300 samples a day, whatever that may be. In addition, I think that the other thing about this is that in not, having so many reruns that can be costly, that accuracy and efficiency is also important because it helps ensure that those formulations are yielding accurate and reliable results. And this is important in states where there are specification requirements. So things like label claim, if you don't have accurate numbers, then you're going to have failures and then clients are going to be unhappy. Additionally, we touched on this briefly, but due to the constraints of instrumentation that's being used in the industry, as well as the standards that are available to laboratories, dilutions for potency can be up to a 10,000x, which means that the slightest error can drastically impact those final results. And so laboratories need to recognize that and need to figure out how they can improve their processes to ensure that that dilution is not causing those errors. And then finally, it's also ensuring that that preparation yields an accurate value is going to help prevent any THC concentrated products from yielding results over 100%. And while this is something that I wish we weren't having a conversation about, it is something we have to have a conversation about, because I can tell you we have seen several COAs on the market that have THC distillate coming in at over 100%. And that's not really possible, right? You can't have more than 100%. So how do we ensure that our processes are not skewing our results to a point where it's causing error like that to occur? Ultimately, at the end of the day, it really is the laboratory's responsibility to produce accurate, reliable, and legally defensible data. And to do this, things like how accuracy is impacted by efficiencies must be taken into consideration before being implemented in the laboratory. Thank you all for your time, and hopefully now we can take a couple of questions.
Thank you very much, Jini. A fantastic session to kick off the event today. We are now moving on to the Q&A section, and as with all the talks, we are likely going to have lots of questions from the audience. I can see we have received some already, so I'll move on straight to the Q&A. You've pointed out some valuable streamlining processes, and in the course of implementing these, did the lab assess the gravimetric preparation and its potential impact on result accuracy?
So we have done a little bit of investigation with gravimetric prep, and while I would love to do a little bit more and dive into it a little bit deeper, the initial kind of results showed that, gravimetric, of course, you're going to get those theoretical values, the exact values, you're going to know exactly what you're adding. The issue with gravimetric prep is it can be extremely time consuming. You have to weigh your vial, you have to add your sample, you have to weigh it again, you have to add your solvent, you have to weigh it again. There's so many additional steps that for a commercial laboratory, I don't really know if gravimetric preparation would be feasible. For a research laboratory, yes, gravimetric is the way to go all day. It's going to give you that very accurate value, but is it feasible for someone in a commercial setting? I'm not sure.
Thank you, Jini. Beyond sample prep, are there any other factors that may affect the precision of potency data? And has the lab looked into these aspects?
Yes. So actually with this, we looked at one of those previous slides that talked about how, sample collection, sample homogenization, data analysis, calibrations. There's so many different ways that potency can be impacted. And our laboratory has taken a pretty deep dive into all of those different things. So there's definitely, it's definitely not just in the sample prep. The way people are homogenizing samples can cause a skew. The way people are collecting samples. If you're not doing a random non-biased sampling by a third party, then we're seeing skews there because people are picking the best of the best bud to test. And that's what they're looking at. It's not fit for purpose testing. So there's lots of ways that we're seeing these skews on potency. And I think it's going to take some time for the industry to really dive in and see each of these things and fully understand the impact that it's having on these final numbers labs are reporting out.
Processes involved in potency prep can vary depending on the complexity of the procedures. Can you provide some examples on what types of training does the lab offer to technicians and analysts concerning the procedures associated with potency preparation?
Definitely. So our potency department definitely goes through the most training of most departments, especially when it comes to the prep, because there is so many areas where things can happen and things can go wrong. So the technicians, whenever they first come in, the first thing they are trained on is weighing, and that's a pretty extensive training. They have to weigh the same sample repeatedly and show that, one, they can weigh it accurately and we can get an accurate number. So they would weigh the sample, and then an experienced technician or analyst would dilute the sample to show that those sample weights were correct in producing that reproducible data. And then when it comes to dilutions, that's a whole nother thing. We use the gas tight syringes, so it takes some time. We do, masses and volumes and syringe training 101, where people are taught how to use a pipette, how to use a syringe, how to use a bottle top dispenser. And then before actually analyzing samples, they are required to prove that they can use that gas tight syringe and produce numbers that are reproducible. So, you should have a tight RSD between what you get when you take one sample and you weigh it and then you dilute it 7 times. We should see the same result each time you dilute it because it was weighed only once. And so we do things like that to ensure that before they start processing samples, they have received the proper training for that preparation procedures.
Thank you, Jini. Before we move on to your next question, I'd like to take a moment to remind the viewers to submit any questions they may have to the chat system to the right. And for your next question, does the lab believe that similar processes should be put in place for other areas of the laboratory to ensure accuracy for all analysis?
Yes, definitely, for sure. I think that potency is one that everybody wants to focus on because of the issues with potency inflation that we're seeing and these high THC numbers that we're seeing. But I think that accuracy is extremely important across the laboratory as a whole. So when we're looking at a lot of the other things, we're looking at contaminants, things that could be dangerous for human consumption. So we need to make sure that whatever processes each laboratory is implementing is not going to affect that accuracy and their ability to get a number that is accurate, reliable, and at the end of the day, legally defensible. So I think that we have gone through a lot of our departments, and before we implement anything that makes us more efficient, we do look at how it affects our accuracy. We go with the old way and compare it to the new way and do comparison results. So there's a lot of validations that need to be done when laboratories are considering efficiencies and how they can streamline their processes and make their processes simpler to ensure that whatever is being done is not going to negatively impact that final result that they're reporting out.
Thank you so much, Jini. Unfortunately, that's all we have time for today. Any questions that we didn't have time to get to will be sent to the speaker after the event. As with all the other talks in the event, this talk will now be available to view whenever you want for the next 30 days. That just leaves me to say thanks again, Jini, for presenting and opening this year's Science of Cannabis Testing. Hopefully, your talk has offered valuable insights to our viewers on optimizing their potency processes. And for everyone else watching, we'll be back soon with the next talk.
Thank you. Have a great day, everyone.